Today I am at Alula Woodworks project here in the Berkshires, and not because we built it, but because I believe that great builders learn from other great builders. I'm going to walk you guys through all the really interesting details of this project, including the granite boulder that supports the corner of this building. And this project is really special. It's called the Fineling, and Vincent is joining me. He's the architect on the project, and I'm going to start with the most obvious thing, is these granite essentially supports that hold up this house. Walk me through the inspiration behind it.
The clients for this project had a difficult experience on this property, and they called us and they asked, could you design us a home and a process that was really regenerative, that helped kind of heal the relationship that they had with this land that's really precious to them. This is a kind of wonderfully abstract question for a project. We translated that into what you see here, which was a kind of close reading of the landscape. We found this old New England stone wall that you can see here, and that on the edge of this woodland inspired the idea of having the house rest on glacial erratic boulders. And there's this relationship between how those stone walls came to be in New England, the kind of freeze-thaw, heaving them through the deforested landscape in the 1850s, and the farmers clearing their fields to build them. And then us thinking, oh, well, we can find some of these glacial erratic boulders on the site. So the two that you see in that wall came from the property. And then these two big ones came from a quarry nearby. One is granite, this one closest to us, and that's actually gneiss. They're formed around the same time, like 1 billion years ago.
And you said it's called gneiss?
Gneiss, yeah. So gneiss is a metamorphic rock, and granite's igneous. Not to get too technical, but they're like brothers and sisters from different time periods, but they perform similarly. They have a similar compressive strength, and they have a really unique character to this landscape. So that became the idea. How could we have a building and architecture that relates to the landscape, but in a very, very unique way? It doesn't take for granted any of the kind of normal conventions of a home. You
had mentioned at one point there's something like 250,000 miles of stone walls.
I've heard there's like 240,000 miles of stone wall in New England.
Someone in the comments will let us know we are wrong. You related the home to that wall when you found it. It situates right over the top of that. What's interesting is, like, if you kind of remove the fact that they're rocks, it's really no different than if you were to post down, because these rocks sit down on what is a concrete footing, right? Is that? Yep,
so the concrete footings under these are obviously a little larger than normal footing because they also have to accommodate the load of the boulders themselves. Sure. Essentially, from an engineering perspective, these are granite columns, and the compressive strength of granite, 1 by 1 foot granite column could hold anywhere from 900,000 to 9 million pounds, depending on the specific PSI of that stone. Of course, we're engineered to the conservative end of that, plus a 5-degree safety factor. The engineer was incredible on this project, but essentially, we realized this is not that much different than trying to put a home on granite columns. Of course, we had to do our due diligence with the quarry and understanding the integrity of these particular boulders.
How do you do that? How do you ensure the integrity is something that when you rest the home on, it doesn't crack?
Quarry that we worked with, Chester Granite, Alan, who runs that, he knows how to read that stone, checking for fissures. This is material that his family's been pulling from that quarry for generations. And so he knows how these perform. So these are particularly beautiful stones that were selected, but they're also the result of a lot of investigation and research.
You think about like on our other Echo Pond project, we're blasting on that, and you're watching rock. Some of it stays in large pieces, and others blow up into tiny little pieces. So it's those are the things that I think are interesting when you work with someone that is a quarry master and understands this stuff and says, yeah, that's going to support the load. I mean, the home is nowhere near 900,000 pounds nor the 9 million pounds. Quite literally, this is what we can call it over-engineered in terms of the column sizing, but it's designed for the aesthetic. Going from stone, we have this, what I call a steel crib system, right? And you essentially have built what is almost like in the absence of a concrete wall.
We tried to do this out of heavy timber, but it was cost prohibitive. The thing about granite is the compressive strength. It exceeds what we'd possibly need. It has good lateral performance too. We have to be very careful that it's not migrating across the landscape, or we're really getting any racking into those columns. So the steel frame acts as it's a kind of moment frame, as a platform. Sure. That's pinned to these. So there's a big stainless steel pin at the bottom, and then there's 4 bolts at the top. And that, this thing's not going to move. But if it did move,
it would move
yeah, this
together
is
as
staying
one,
there, yeah.
as kind of one unit. And then from there, dare I say, more traditional in the sense that you've essentially packed out the steel webs and then have infill framing here, which will essentially get a heavy insulation layer.
Exactly. So, this project actually has a pretty modest budget, and there are some kind of high performance envelope considerations, but it's not over insulated. It doesn't have continuous exterior insulation.
Sure.
These sort of additional moves. So we have R60 in the floor, which is floating here, and our thermal bridging through the steel is dealt with simply by having timber framing on top. We don't have like an additional foam thermal bridge.
Right. So you see up there on the top of that flange, you have a double stacked 2x. You're going to plywood over this,
Yep.
which will be completely air sealed, I assume. As cold hits that and tries to transfer up, you still have that kind
a little bit of break.
buffer.
Yeah.
Right.
Yeah.
You said something I think really important to this project is that the project has a modest budget. The reason I want to call attention to that is because it is really unique. It's really special. There's a lot of interesting detail here, but you're doing it with a modest budget. And I'm sure the granite wasn't inexpensive. It's in replace of putting a foundation or even excavating, really. You're excavating a small spot to put a footing in. So you're playing with these kind of moments of construction where it's, you're being a little bit more unique on the design side and being intentional with it, but you're doing that within a modest budget.
Yeah, it's really assigning value in the budget to what's important for the architectural experience.
You have something really cool here, but before we go up into that, I want to go back outside. One of the more dramatic moves here, I think, are these overhangs and also the timber. And correct me if I'm wrong, it's larch.
Yep.
Right?
This is larch. Tamarack is the specific name, and that is a species of tree that's native to the area, and a stand of trees in upstate New York that someone maintains. All this material came from that same stand. And it's not just the roof framing and cladding. All the interior finishes are one material. And that goes toward this notion that we wanted to create something kind of holistic and really warm and really related to this place. It's a fast-growing kind of mid-succession tree, but it's very similar to a Doug fir, but a little denser. The grain's a little tighter. It has more pitch in it. It's nice material for kind of some finished carpentry.
Judging by what I'm seeing, it's 5.5, maybe 6 foot overhang. And that's a big overhang. You have these essentially what I think are about 4x10 or 4x12 rafters that overhang that create this really interesting detail. And if you're watching the video and you're looking at it, it may almost look as though you have a board and batten that's painted black, but that's actually...
That's a rain screen. So you can see a mock-up we've made of the open joint rain screen here.
So that's actually a membrane, not a tar paper, which looks like. So what is that detailing and what is your finish detail?
This is a Proclima product called Fronta Quattro. All this is a WRB that's airtight and is UV stable. And it's designed for applications where you have an open joint rain screen. So the larch material on this mock-up is open joint, and whether UV will move through that, it's all black. So all the badging and lettering on it is all blacked out, and they provide a tape that's all matching. So when you look through, you just see a dark shadow line.
Sure.
And then our strapping for the rain screen, again, this is just vertical strapping. Because you're going to end up with a 3/4 inch air cavity, we thought in this case, let's just make the rain screen open entirely so it can dry even more. And then we paint the vertical strapping so you don't see those joint lines.
The UV is something that's really important. WRB, typically when you're installing it, has essentially, this is how many days it can be left exposed. And this will always see sun, and of course it will see rain with the rain screen, but that's something that has to be considered when you're doing an open joint. I think that's important if you're considering doing a detail like that, using something that is UV stable.
And also because this building is, I'd say, a little thinner than we usually would design from an insulation perspective, getting air sealing on the wall assembly, if you can't make it airtight, it doesn't make any sense to insulate it. So that works as an air barrier, and our interior membrane does as well. We're going the extra distance to keep the wall assembly airtight, and then feel good about the R values that are in there.
So that's an 18-foot wide glass, no mullions, glazed in place unit.
Exactly, and one of the ideas here to really increase the architectural expression and maintain our cost was to glaze the windows directly into jambs that were built on site. And so anywhere where you see glass, it's fixed. There's no operable glass on this building. On the side of the building, there are panels that just shutter open with insect screens behind them.
Let's go inside and look at that.
Yeah.
So obviously this is a construction staircase. What is the final condition here? I see you have some screw piles that are going to support something probably pretty beautiful here.
We left the techno posts tall. There's a laser cut stainless steel stair that's perforated and has traction tread on it. The whole thing's really custom metal work.
So pause, because earlier we talked about a modest budget. And I think this is a great example of someone's like, well, there goes the budget, right? Like this custom laser cut, special stainless steel. The reality is, you know, these are the details that oftentimes, you know, we work through on our projects where it's like, you just have to think about the appropriate way to accomplish that.
Working with the production systems in place for local fabrication made all the difference. This was originally designed, and you can see it in the initial renderings, as a CMU stair, because we thought that there would be no balance in the budget and we didn't want to take it from the contingency at the start of the project. So the design was for just simply stacking CMU on a concrete pad. What we found was, as we were about 25% through the project and hadn't really touched the contingency, we said, oh, let's come back to this and try a different version of the stair. And it actually priced out almost the same as doing the CMU and the concrete pad.
Your comment about working within the parameters of like local fabrication shops, you might design a staircase that's 4 feet wide and his machine is more efficient at 3 feet wide. It's things like that. Asking the right questions is going to really allow a project to work within a modest budget. Now, I was surprised about this, but as I came up the stairs, I was like, oh, is there a skylight above me? And it's not a skylight. We're in what is considered a courtyard?
Yeah, I'm not sure exactly what we call this yet, but this is open to the sky, and all the purlins there will be cut back. So it's a courtyard over the stair, but it's this moment the building really hugs you. And so in response to that client brief about creating something that was healing, it's literal, it's not so metaphorical.
Yeah.
You enter through the middle of the building, which is also, you know, most buildings you enter from the side. And so to change the topology of how you enter the home was really important.
I love that. And we have a super insulated door here, I see.
A temp construction.
Temporary.
Door, yeah.
The 18-foot glass door from the inside, this is what you were talking about. Everything is built in place, all large window frames. And correct me if I'm wrong, Sean just purchased panels of glass.
Yeah, we just specified double pane IGUs. And initially we were trying to get one piece, but to optimize the budget, we broke it into 3 panels that are wet glazed, so there's no mullion in between.
Well, it's probably obvious to many, but 18-foot long piece of glass, it's a huge piece of glass, single piece. To optimize the budget, you separated it in 3, which still, I mean, it's beautiful. Roughly, what is the savings to go from a single to 3?
Well, the savings to go from a single to 3 was around $6,000. The real savings, though, was to do just the IGUs glazed into the wood frame on site. Because when you're buying operable window or a fixed window with an insulated frame, you're paying for all that production cycle. The reason there was a delta in the cost between a single pane and making it 3 panels was also the company providing it. That size was outside of their wheelhouse. And again, this has to do with working with local resources, local trades. They were excited to do the full-size panel, but they would have had to rent different equipment they didn't own. And so when you really get under the hood of everyone's capacities, this is the optimized version of it.
And you think about even just installing it, I mean, the panels are going to be, you know, one big panel requires a very different crane or suction cup or lift or whatever to install it versus these, you know, which technically probably could be muscled in by hand.
Yep, and the topography, you know, on the outside of the building makes it challenging for equipment around the perimeter of the building, so that was another reason. But, you know, the consequence of thinking this way and having all the glass fixed, huge portions of the wall that are just shutters. And so on the exterior of those shutters, it'll match the rain screen, so you won't really notice them from the outside. The inside will be paneled with larch, like the rest of the space, but you can open that for ventilation.
And so there's no light coming through that?
Yeah, when you open that, it'll let light and air in. When that shutter is completely open...
But when it's closed, there's no light?
There's no light, correct, yeah.
So, okay.
You can see it in our rendering, that opening's above the kitchen, And then on the other side of the building, that opening is above a bookcase and a desk. So you have great cross ventilation. And then on the other side of the house, there's 2 more smaller shutters in each of the bedrooms.
When you say shutter, I think of exterior shutter, but it's essentially a door?
I guess, yeah, it's a door. I mean, this
Yeah.
is a back and forth because it's an unusual move, but
But
it's
satisfies egress and things like
Yeah.
that? It's an interesting move and one that I've not considered before, where it's like you always think about glass and windows being your means of
the
egress.
operable portion
right?
of it. Yeah.
And in this case, you're essentially just putting a door that opens up to. Do you have a insect screen or?
Yep, a kind of twist-in insect screen that has kind of 0 sight lines,
Yeah.
and this is really simple to use. One of the other benefits is you can insulate that wall panel essentially
It's just
better
an operable
per
wall panel.
dollar
Yeah.
than you could if you were trying to buy the comparably insulated glass.
We're finding. I'm finding different names for what you were calling shutters: doors,
Doors,
operable wall
yeah.
panels.
Wall shutter. Anytime you're trying to make high performance glass operable, it's possible and there's incredible products for it, but they come at a premium.
Sure.
And so this is just kind of moving the first principles of the building component
Yeah.
around and not asking the glass to do one thing and having a wall shutter
Right.
do it instead.
The envelope of the home. So I see you have some PSL posts that transfer down. Walk me through the overall structure where we have the steel crib, the infill. So I think the floor system is pretty straightforward, but in terms of the rest of the building, what considerations had to be made for the structure?
Yep, so once we're above that steel platform, we're very much traditionally framing a building on top of that. We had to coordinate penetrations through the steel, obviously, for our utilities. It's a 2x6 wall, R23 insulation. Our floor assemblies are 61 plus. And then the roof rafters are 2 layers of Rockwool R53. And there's 1 ridge beam, and the larch rafters extend out beyond. Now they're taped. Maybe you can see one here. Again, a kind of cost consideration was that we took the larger larch rafter tails essentially and bolted them into the 2x material for our roof framing.
You would think that those are the continuous rafter all the way throughout.
Originally we had designed it that way, but again, to really optimize costs, this was one of the optimization
Yeah, I mean, you're
decisions.
saving a couple hundred linear feet of larch.
Oh yeah.
You're getting that aesthetic, and then you're switching to I see is like a false ceiling in here.
Yep.
Does this get larch on the ceiling in here?
Everything inside is clad in larch. So originally we actually tried to do the whole building out of only larch, even the framing, all of it, heavy timber, no steel. So it'd just be glacial erratic boulders and larch from that forest. But there was a point during the design process where we came in basically like 300% over budget when we looked at it in larch heavy timber.
Yeah. Something we didn't look at outside, but I see that there's plumbing. There's a bathroom here. There's heating and cooling. How are you dealing with, once it penetrates through the floor, how are you getting your plumbing down? Is it a traditional stack that is open to the elements? How are you getting your water in here?
So we have 1 mechanical chase that leaves the building from a little mechanical room in the back, and that's an insulated chase with heat trace.
Right here.
Yep. Below here where the electrical riser is. And so that goes down, branches to a condenser that's outside in the woods, and then our septic and our well.
And then so that water's just coming in. So I assume it's going to be similar to our cabin. We have a cabin that's sitting up on stilts, and the well will pump water to the house when needed, and then it drops back down below frost when you're not calling for water. Right, got it. And you said that's all heat trace, which means it's insulated with a wire that prevents...
Yeah, there's a really high quality heat trace, which is a belt and suspenders. I mean, it's insulated, and that insulated chase will come through the floor here, so it's going to pick up some of the temperature of the building into that cavity down to below frost anyways.
Got it. So you're in essentially like almost a conduit.
Yeah, it's an oversized conduit that is going to be wrapped in essentially roofing sheet metal, so it looks elegant. But the heat trace is there as a backup. This area, the Berkshires, get into the negative 10s, negative teens easily.
Where are we right now?
So this is one of the 2 bedrooms, and this is another example of the glass panels glazed directly into the wood larch frames. There's a platform with a bed here. So there's one of these shutters in the back. Next to that shutter is a little closet, and then under the beds is a kind of pull-out storage.
Yeah.
And it's very, cabin in the woods was the idea.
Bathroom behind here. Looks like you have a pocket door for this room, which is a great space-saving detail. The room can stay open. one bathroom in here?
There's just one bathroom, and it's a open concept bathroom where the shower, the toilet, the vanity are all in one space. And you can see in the rendering, the top of the vanity is made out of a single large log that's been cerused black. And since everything's going to get wet, it's a powder coated metal cabinetry. And then all the switches and everything else are in recessed panels in the wall. And this will all be plastered, so everything's a wet finish in that little bathroom.
Your awesome detail with dropping the subfloor. Speaking of switches, I noticed, number one, I appreciate the switch height. I think that's one thing that, I have learned to almost obsess over at this point, that switch heights are typically too high.
Yeah, you kind of want them where your hand is landing anyways.
And
it's
it makes it terrible for kids because then the kids just play with it more. Speaking of switches, I noticed this when we walked in here. This is what looks to be, I have no idea, actually, a sideways box.
Yeah, so this is a 6-gang switch plate. The product's by Forbes and Lomax, and they're going to be...
That's not an inexpensive switch.
No, it's not actually, and it's a totally asymmetrical use of the budget here. So those switches are expensive. They're stainless steel radial dimming dials, and we don't have too many of them on this project. And because of it goes back to where you assign the budget and what you try to optimize for in the architectural expression, because we wanted everything that you touch to have a hand, to feel like it was a piece of furniture, feel like it was a natural finish and material.
Yeah, and like you said, it's not a big space, so sure, you're overspending on a 6-gang switch.
We have 12 custom switch plates, and it works. Yeah.
So percentage-wise, it doesn't make a big difference. So you come in here, is this mudroom, closet?
Exactly. So this is the entry foyer, little sitting area. Hang your coat, take your wet boots off.
This is coat closet.
Yep, that's coat closet.
So are you overheating this to dry your clothing?
No, we're returning.
Oh, you're using this as your return?
Yeah.
Oh, so you're hiding your returns within the closet.
Yeah, and the doors are open on the bottom, and then below this wall, actually the framing needs to be cut out here, but there'll be a grill behind this chair. So we really tried to hide everything. The only
let the building be the building, the larch be the larch, and
exactly.
not walk in and have a 24 by 24 off-white grill on the ceiling.
Exactly. Again,
I thought they were jacket warmers.
Yeah, it's ski and boot warmers. But also to that point, Nick, it's a small building, but by keeping the doors full height in here, the airflow is uninterrupted at the ceiling. So if you really looked at the fluid dynamics of the space, it performs much better than having the dropped header over your door, because you're getting all that air exchange.
I think that is such an underappreciated detail. It's just so much nicer looking when you have that floor to ceiling, and there's expensive ways to accomplish it, but you're looking at here, it's just thought through.
Yeah. So this is another one of those bedrooms, and it's essentially the mirror of the other side. And through this bedroom is a large storage area and a mechanical room.
This could be a third bedroom.
The clients wanted a lot of storage up here. They wanted to be able to pile, all the kids' toys and stuff and games somewhere. So yeah, it's a small building, but a lot of different programs accommodated.
Vincent, I appreciate the invite here, and big thanks to Sean and Katie from Alula Woodworks. I mean, they've done an incredible job, and what a cool project. I think we're going to be back with a little bit more progress as this project progresses. It's not something we typically do, but this is about sharing visionary projects and really inspiring projects. And Sean and Katie were so nice to allow us to come here and check it out.
Thanks for coming out, Nick. I really appreciate it.
See ya. If you guys are interested in building something like this, feel free to click the link below and set up a consultation call, and we can talk about your project.